Logic, example 13. Two statements are logically equivalent if and only if they have the same truth values. The symbol for logically equivalent is as follows. So we're asking if the negation of the conditional statement if P then Q and the statement P and not Q are logically equivalent. So I will use truth tables to figure that out. So let's first figure out the first statement. So P, if P then Q. All right, so the only one that's false there is the true false. So we'll put false and then true on everything else. And then we need the negation of that. So false, true, false, false. All right, so now let's look at the next one. Let's find the negation of the Q first. So that's false, true, false, true. And then we need to look at the conjunction of P and not Q. Okay, so in this situation, we just want this column and this column right here. So true, false will give us false. True, true is a true. False, false is a false. False, true is also a false. So at this point, we need to look at this column and this column. Do they have the same truth values for the original values of the P and the Q? So false, true, false, 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 true, false, false. Yes, they do. So are they logically equivalent? Yes. All right, let's look at example B. Oh, I want to point out that on 13A, that was our negation of a conditional. So we are basically proving what we had talked about before. And for B and C, we are going to prove De Morgan's law. Okay? So we need to figure out whether or not this statement is logically equivalent to this statement. Okay? So let's first find the truth value for the conjunction of P and Q. Okay, so the only one that's going to be true is this one right here. Everything else will be false because true, true is the only one that's true in a conjunction. Okay, now we need to find the negation of that. So false, true, true, true. All right, so on the next one, we need to figure out the negation of P, and we need to find out the negation of Q. That won't be too hard, will it? So the negation of P is false, false, true, true. Negation of Q is false, true, false, true. Now I need to find the disjunction of these two. So in a disjunction, the only one that's going to be false is the false, false. So that will be false. The rest of them will be true. So now we're figuring out, are these logically equivalent? Yes, they are. Okay. So then the last one is we're going to look at the negation of a disjunction. And we'll see if these two are logically equivalent. Those two statements are logically equivalent. All right, so the first thing I need to do is find the truth values for the disjunction of P, Q there. So remember, on a disjunction, the only one that's going to be false is the false, false, and everything else will be true. And now we need to find the negation of that. Okay, so it's false, 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 and then true. All right. So now let's find the negation of P, the negation of Q. So false, false, true, true. false, true, false, true. And remember, the only one that's going to be true on the conjunction is that they're both true. Everything else was false there because it had at least one false. All right, now let's look at our statements and see if they have the same truth values. So, sorry, this was logically equivalent up here, and so is this.